Hello students, how are you? Alright, in the last session we had done the introduction of integration. I took up one question based on integration where you had to find out velocity when you knew the value of acceleration. So when you know the value of acceleration, obviously time variable, time varying value of acceleration, and then you need to find out the value of velocity, the velocity value at a given moment, at a within given time interval. So in a very similar way, if you have known value of velocity, you can find out the value of displacement in a given interval, right? So there you use the value, what value? There you use the value of the tool which is used is integration, right? Basic formula we have taken up, and in today's session also what we will do, we will take up few advanced questions, right, where integration is used. Integration, tool of integration is used, right? So let us quickly understand. Before that, I have one more question based on differentiation we have done, just to review it quickly, try to understand what is it. This is very simple question, right? So the displacement is known to you. The displacement of a body is given as S equals this. Mind it, where T is in seconds and S is in meter. All right. Find out the value of velocity when acceleration is 0. So this is based upon what? This is based upon differentiation. I have taken this question intentionally in today's session just to differentiate how and when, basically, when integration is used and when differentiation is used. Here, the situation is this: we have displacement and we have to find out the velocity. We have displacement and we have to find out the velocity. Velocity equals ds by dt. We are aware of this, right? Where s being the displacement, right? And we have to find out velocity. We have to find out the velocity when acceleration is 0. So again, with respect to time, you need to differentiate v. So acceleration equals dv by dt. Whatever value would come here, you will put that value to be 0, and then since acceleration will be obtained in terms of t, then t value would be known to us. And that value of t we will substitute in the expression for v that we will determine right now. That will give us the required result, right? So here we are not using integration. We need to use here differentiation. Very simple. You have got the expression right here. So just quickly do this, okay? How we are going to do? We have s, so value of velocity. Quickly, I know you can determine velocity value would be, velocity would be what? 3t square, mind it, 3t square minus 12t, okay, plus 3. This is velocity. This is the value of velocity. But we need to find out the velocity when acceleration is 0, the moment at which acceleration is 0. So obviously we require to find out the acceleration also. So just find it out. Acceleration would be dv by dt. Now once again differentiate this velocity with respect to time. If you will do that, you know the basic idea behind it. So acceleration is going to be 6t minus this 12t, that means it is going to be 12 only, right? 6t minus 12. We have done enough of differentiation, and I am sure that you would be able to get this result quickly. So we have got this expression. Right? Now, what is given situation? Acceleration is 0. So if you put this thing, this 6t minus 12 equals 0, then value of t is equal to be what? 2 seconds, right? Value of t is going to be 2 seconds. That we need to find out, okay? That we need to. So this is the moment when acceleration is 0. So now this value we are going to substitute in what? We have to substitute this value of t in this expression, because our required result is this. We had to find out the velocity, the value of velocity, right? So put this thing here. So what we are going to do? We are going to get v as 3 into this square of 2 minus 12 into 2 and then plus 3. What we are going to do, just take it up. So 4 into 3, 12 minus 24 plus 3. Okay. So minus 9. Is that okay? Yes, this is minus 9 meter per second. So this is our required result. Okay. Here, very important aspect. When we have velocity in positive and we have velocity in negative, what are the implications? What are the conclusions we can draw? This is very important. If we have suppose motion along, if we have motion along x-axis in this direction, let's say, okay, positive x-axis, it goes here, If it takes a turn, then what? Velocity in this direction was positive velocity. When it goes in this direction, if it takes a turn here, and now what? It moves in the opposite direction. If it takes a turn, then velocity is negative in this direction, right? This velocity becomes negative when it takes this turn. So that we need to understand. When velocity is minus 9 instead of plus, that means it has taken the opposite direction, right? Opposite direction. That was the basic idea behind that. Okay, so we will talk about this in much detail when we strictly talk about the direction of velocity, direction of acceleration and things like that. We will talk about this in vectors. So right now strictly we need to understand here the calculus based concepts of velocity, acceleration, displacement. What are the relations among them, right? That is our agenda at this moment. So quickly we have understood what we have understood when differentiation is used. You are able to understand, right? Now we will take up the questions. Next question, let us take next question. So here we have to use integration. Why that? Why? Just focus on the question. Just read the question. See what is given to us. Acceleration is given to us. This is acceleration. Mind it, we have acceleration value and we had to find out the displacement or distance, whatever it is, right? Distance at which particle stops. Condition is given that initially, yes, initial velocity is this, V0. V0 is initial velocity. Initial velocity, when you say initial velocity, that means at t equals 0. Initial, when it started. So acceleration, and mind it, when it started off with, the body has started off with some velocity. When the velocity becomes 0, when it stops, the velocity becomes 0, there must be some retardation, right? Retardation means negative acceleration, you can consider it. So that expression is given to us. Acceleration here is given in terms of displacement. So we need to be very, very careful about this. Acceleration is given in terms of displacement. So we need to think about the expression of acceleration in terms of displacement, right? So this is alpha x square. So is this positive or negative? This is negative. Why negative? Because particle started off with some velocity and it is stopping, it is becoming zero. That means velocity is decreasing. Velocity is decreasing and negative acceleration is happening. So negative acceleration, okay. So final velocity is 0 at t equals, don't know, whatever, at t seconds, right? T seconds. From the start, from the beginning, t second has been spent, and t second, after t second, velocity becomes 0. This is the given condition. What are we need to find out? We need to find out the distance, right? That distance would come in terms of this alpha, alpha and velocity, initial velocity. Okay, so quickly, what we need to recall here. First of all, we need to recall the value of acceleration or expression of acceleration in terms of displacement. How we can go with that? Just have a look. So acceleration equals dv by dt. We are aware of this. If we simply multiply this with dx by dx, what we are going to do is acceleration equals dv by dx. dv by dx equals dv by dx multiplied by dx by dt. So dx by dt is v. So A is coming out to be dv by dx into v, right? This is our expression. Here, this expression is quite useful for us. Why? Because acceleration is given in terms of displacement, and they're asking at the moment velocity becomes 0 from some, it is starting off with the origin. Okay, it's starting off with the origin. Suppose this is origin, and it is going in this direction, right? So it started off with velocity v0. Now here it is stopping at this point. What is the displacement value or distance covered in this? See, when there is straight line motion, distance and displacement can be considered. It is in this direction only, it is going up. It is going in this direction, so it's okay to call this distance. When there is a change in direction, then displacement comes in. So here we need to find out displacement value, right? Displacement value. So from the origin, x equals what? Position was x equals 0. Here x equals s. So that we can find out. S we need to find out. Okay? The value of s we need to find out. It started off with velocity v0, and here it comes to be this. In terms of t, if you consider at t equals 0, now this is at t seconds, right? So this is what the picture that we need to keep in mind. See, in physics, if you really want to master any concept and application of the concepts, it is quite advisable that you visualize each and everything. If you can visualize it, with the, if you can relate with the day-to-day life, relate the things connected to your daily life, then what? Then it will be easier. Whatever is given to you, just visualize it. If you visualize it clearly, in the mind you have the clear picture, then applying the concepts would become easier. Right? So look into that. I know that might be a little difficult in the beginning, but when you would do this, even the bigger difficult problems can be solved easily. Right? Okay. So let us quickly move ahead. What we have now, acceleration equals dv by dx into v. All right. I'm quickly doing this here. What? dv by v into dv by dx equals minus alpha x square. This is acceleration. Acceleration equals minus alpha x square. This is given to us. I have put this v into dv by dx, for a. Now, just have a look. What we are going to find out. So x you will take up here. Okay. So v into dv. All right. Now, what is the limit? Limit would be. What would be the limit? Limit would be v naught to 0. Okay. This is minus alpha x square into dx. This dx, which was on the left hand side in the denominator, this goes here. So this. Now we will integrate this also. So 0 to s, mind it, 0 to s. This we need to solve. This we need to solve. Right? And if we find out the value of s, when we have the expression, we would have this expression in terms of s, and then we will equate it to find out the value of x. And then we can say, okay, some constant must be there, and whatever is the value that we will need to determine. So let us think about it. We can have this, what? V into dv. When we say v into dv, let us quickly understand. Let us quickly understand that when we have v into dv, this means v raised to power 1 into dv, right? Right? In this case, what we have, apply the formula. What is the formula? This is the formula, t raised to power n, or you need to consider this, that any variable can be there, right? Any variable can be there, right? It could be in terms of this also, x raised to power n into dx. But we make sure that this variable and this variable has to be same. These two have to be same, right? Here t, then dt, it is multiplied in this manner. So t raised to power n plus 1 divided by n plus 1. Here in this case, in the case of x, what is going to be? X raised to power n plus 1 divided by n plus 1, right? So this we have understood. So here what? V raised to power 1 into dv, the way we have done that, we apply it here. It is going to be 1 plus 1, that is 2 divided by 2, right? So this is 1 plus 1, that means this is 2, okay? This is v square by 2. This is what we are going to get. Okay. Now, just have a look. So this v square by 2, right? And then we have what? We have limits to be from v0 to 0 as per the given situation. This equals, okay, here minus alpha is constant, right? Alpha is constant, so it is taken out of this. Now x square into dx comes out to be x cube by 3. All right. This is the expression. Now let us move further. What we have? We have v square by 2, and the limits are from v0 to 0. Limits are this. And on the right hand side, what we had? Alpha, minus alpha into x cube, and the limits were 0 to s. So minus alpha x cube by 3, 0 to s. Okay, if we solve this, we find out the value of s, and then the problem will be solved, right? So just have this. Okay, so we have this idea. I have taken this denominator thing here. Okay, 1 by 2 I have taken. Now value this, these are the values of this, right? V. So in the beginning it is upper limit minus lower limit, mind it. So here this one is considered to be 0. So 0 square minus v0 square, this exponent as it is here. You subsequently put the value of v0 0 first. This is upper, this is lower limit. Here you have got minus alpha minus alpha by 3. Okay, s, upper limit here is s, so s raised to power 3 minus 0 raised to power 3. This is what we are going to get. Okay, if you will look into this, this value is coming out to be negative, right? So negative v square. So if we put it negative v square by 2 equals here minus alpha by 3, and this value is coming out to be s cube. All right. So something is coming up? Yes, something is coming up. Let us quickly understand. Okay, this negative gets cancelled. We can consider this. Now what will happen? 3v0 square by 2 alpha, 3v0 square by 2 alpha equals s cube. So what is the result? The result is s equals 3v0 square by 2 alpha raised to power 1 by 3. This is our result. This is our result. I know this is little complicated. It appears to be little complicated. There are so many aspects we need to be, paying attention to. But if you have the practice, if you have the clarity, okay, we have started off with this. What is the given situation? And you start working on it. You are going to master this mathematical tool, and you would have no worry about applying the concepts, right? You would have no worry about this, because these sort of questions you might encounter in NEET. If you are preparing for JEE, there also you might have this sort of questions. So what I believe strongly, that if something is, something appears to be difficult, master it first. Master it first. If you do that, believe me, you would have no worry. You can aim higher. You would always achieve that. When you aim higher in that, with that approach, I'm sure that you will achieve higher, achieve big in your life, right? So, yes, this comes out. This is the result. This is our result, right? This is our result as we got. Okay, 3v0 square upon 2 alpha raised to power 1 by 3. Understood? If this is going to be difficult, then what is difficult? There are so many aspects, as I have told you, that one thing was this alpha in terms of displacement, that is one thing. Okay, interpreting the question is also very important. Interpreting it. It is given that. Why I have taken negative sign? Logic. What logic? It started off with some velocity. Body started off with some velocity from here, from the origin, and as it moves further at a distance, let's say s, it stops. It stops. So velocity becomes 0. When velocity becomes 0, okay, that is given to us. That clearly means that acceleration is negative. It is decreasing with time. It is decreasing with velocity, decreasing with distance, right? Okay, when you apply a brake, that okay, that vehicle or something stops. So negative acceleration. That's why I have put this here, negative acceleration. Okay, one thing. Second thing is that initial velocity is already given, time. Okay, this sort of question could be given in terms of time also, right? But here we have in terms of x. So we need to have this expression. Acceleration in terms of x. Okay, two aspects. First is interpreting the question. Then what is given in the situation, that sort of expression you need to think about. Okay, this is the expression. Now what? Still we have no idea what tool is required. At this moment, only two things. Interpreting the question and then thinking about the given situation, and then that sort of formula. Okay, expression for acceleration in terms of displacement. Okay, third step, what? Putting this here, displacement in terms of velocity and displacement, that acceleration in terms of velocity and displacement that we have substituted here. Here we have substituted, okay? Now we would ask, what is to be determined? Displacement. So in this scenario, we have to rearrange and then use this integration, right? Use integration. So this we have. If you have difficulty in applying the integration, this is the basic concepts I have discussed, okay? And then applying it, whatever we got is our answer, right? So the problem might appear to you difficult in the beginning, but when you have the clarity that, okay, this is given situation and this is the basic concepts I have mastered, I have practiced, it is going to be very easy for you to get the results, and get the result in less time. Get the result in less time. That is the key to succeed in any competition, right? Succeed in any competition. So that we have to be very careful about, okay? So this was done. This we solved. This is our final result. All right. Now, one more question if we quickly do this. Oh, this is from where velocity is given, acceleration is to be found. That is easy, no? That is easy. Differentiation. We have done it all. Okay? This also you would have. Here we have the relation. This relation is given. Okay? This relation. We will talk about this logarithmic function, how to differentiate that logarithmic function or exponential function. There are a lot of different functions that we will discuss in the next session, right? So quickly, in this moment, what you need to do is just master this thing only, x raised to power n into dx, okay? Algebraic function, this we call as algebraic function. Okay, this is what, x raised to power n plus 1 divided by n plus 1, this is the result. Okay, and one more basic idea is this, if values are given, right, if values are given, limits are given, then we have definite integral, we call it definite values. If limits are not given, right, like here, limits are not given, the x can assume, and x can take any value, right? X can take any value, so that is called indefinite integral, right? So we'll again in the next session we will discuss much more other formulas related to integration, okay, and how that how those formulas are used in given problems. That also will take up few questions, and further we will learn more integration formula, right? So till now, whatever we discussed, you practice properly, right? And how differentiation and integration are used. Do practice, okay? Thank you. See you in the next session with